introduce the problem where it is in the original problem. Because after a while, you get lost.
Yeah.
You really get lost really quick. I'm not labeling this note because I really tried to mess you up with this. That was intentional. So that's the first thing, is label the nodes. The next thing is I start a reduction. I'm gonna take CD and go to the right. On CD, I'm just putting it down here because now I'm starting here at C and D. I don't care about the rest. I'm just starting at C and D. Sorry about the writing. Here's my node C. Notice two resistors start at C. I come out and they come right back to this point. So this resistor is definitely in parallel with that resistor. This resistor, I start here, and now I'm here on this resistor, they come back to this point. I started here, which is the same point for each resistor, and I come back. What does that tell me? Same voltage here, then here. Same voltage here, then here. They're parallel. So I just redraw them the way they are. That's my C and D. There's D, there's C, and this is 5, 5, 5, and 5. Now I've got a bridge across here.
So quick question. Those are still in parallel the way that you got it drawn.
This one's in parallel with that one,
Okay.
this one's in parallel with that one. And that's exactly the way they started. Both of them start at C, that's where they are. They end at this bridge, they end here. They both start at the bridge and they end here. One more. 2 5s in parallel. Whenever you have parallel resistors, the result is half. Two 5s is 2.5. You can use product over sum or whatever you want to use. One more. C and D. C and D, that whole thing is a 5 ohm resistor. I started with 2 in parallel, 2 in parallel, 2.5 is the equivalent, 2 in parallel, 2 in parallel, 2.5 is the equivalent, 2.5 and 2.5 is 5.
So after you reduce the two parallel, they end up basically becoming in series.
1 5, yes.
Okay.
Yes,
Okay.
exactly. This whole mess is 1 5 ohm resistor. Parallel to a node, parallel from a node to a node, parallel from a node to a node, parallel from a node to a node, 2.5, 2.5, 2.5, 2.5, 5. And now jump back to A and B. I'm starting here. A and B. A and B. Chris said 10 ohms. That's A and B, okay? And that's right. There's 10 ohms. These, obviously, this first one you see right away, that's 10. Now, from A, I'm going out through 10 ohms. That's him. And down here, 10 ohms. Oops, sorry. 10 ohms. It looks like 16. Okay, so I've got my 10 and my 10, my 2 5s become a 10. This is, I'm gonna put the A above here and B, so you can see that I've just broken it here. And now I've got my 5. This between C and D, here's C and D, and it becomes a 5. So this guy comes down here. I now have a 10 ohm in parallel with a 10, a 5, and a 10. 25 ohms in parallel with 10.
Because when you take that, it ends up becoming in series from A to B.
This is in series because all the current goes through all three, so they're definitely in series, and this is definitely in parallel with that. They started a node and ended a node. So I do another reduction with A and B. And that's a 10. And the other guy over here is a 1025. And then the next reduction is 10 in parallel with 25. And that becomes a single resistor with 7.14 ohms. Product over sum, 250 divided by 35. 10 times 25 divided by 10 plus 25. Or if you want, the inverse of 1 over 10 plus 1 over 25, inverse of that sum. That's a lot longer. 10 times 25, 250 divided by 35, 7.15. Or something like that. If I'm wrong in the math, tell me. So I've reduced this to a 5 ohm resistor. I've taken this with the 5, added the 10s and did this. I'm now up to here with a 7.14 ohm resistor. And 20 to it, and that's my total resistance, 27.14. So the next one is down here, which is here. I'm not even putting any nodes. That's dead. Oh, I can put a green. No, I can put a red here. Now I'm coming down here. Here is my source. 10, 10 volts, 10 ohms, 10 ohms. There's volts here. And I reduced all of this. Here's A and B right here. A, B. And what did A and B turn out to be? 7.14. So that's a 7.14 resistor there. This guy is there. That's my final resistance. 10, 20, 7.14. So I have 100 volts and I have 27.14 ohms, which gives me 3.68 amps total. Which means this is 3.68 amps. This is 3.68 amps. What comes out of here has to come back here. So what's the voltage across here? This voltage is 36.84 volts. 3.68 amps through 10 ohms. 3.68 times 10, 36.8. That's my current going here. This current goes this way, so this voltage is also 36.84 volts, but the polarities are reversed as it comes out, plus to minus, and plus to minus coming back. So there's my voltage, there's my current, there's my voltage, there's my current. Once I get to this point, now I have a situation where I have currents going in two different directions. I've got a current I know that's going to come down here, and I've also got a current that's going to go through that. So automatically I can tell that's going to be my two currents right there. I just don't know what they are. This one I can determine instantly by simple KVL. Any loop will be 0. Any loop, even this stupid little loop, will be 0. So here I have 100 volts, I have 36.84 dropped, 36.84 dropped. So this is 73 approximately volts, 73 volts here. Those two together is 140. Those two together are already 73. I don't need to double it again for me. So I have 36.84 volt drop here, 36.8 volt drop here. Add those two together, I get 74 volts. I take 100 minus 74 and I get what? 26. That's my voltage here. 26 volts from here to there. Because 36 plus 26 plus 36 is 100.
Question for you.
Yes.
So if you have your positive on the top side of that circle and a negative on the bottom side, wouldn't your polarity be the opposite way of what you have it?
My
Because
current's going this way. plus to minus, my current's going this way, plus to minus. My current's going this way. I know the plus to minus, and it'll be plus to minus this way because the current's coming back.
Okay.
All right, is that okay?
Yep.
Okay, so I have 36, almost 37, and 37, 60, 74, and that gives me 26 over here, 74 and 26 is 100. So now I know my voltage, and I had 10 ohms, Chris, you had 2 5s. What's my current in that way? 2.6 amps, 26 divided by 10. Voltage divided by resistance is current. So I have 2.6 amps here. And 26 volts across. That's 13 on this dude and 13 on him. 26 is over both. So now that I know this is 2.6, I subtract 2.6 from 3.68 and I get 1.08 amps. That's my current here, 1.08 amps. All I'm using is KVL and KCL. I'm not using voltage division, I'm not using current division, I'm not using any of the tools that you're gonna learn in the next 2 months. And when you start applying those things, this thing becomes less than 2 minutes. 2 minutes is when you're really laid back. So now you're down to 1.08 going into this dude, 1.8 coming back out. So what's the voltage here? 10 times 1.08, 10.8 volts. 10.8 volts is this guy. This guy is 10.8 volts because 1.08 goes through 10 ohms, comes back on the bottom. So I have 1.08 on C and D, but C and D is broken up into 2 paths. The left and right, they come together, then left and right again. These are balanced. That doesn't mean anything. That bridge there has no current in it. But I leave it because it does exist. But if you can remove that, you get the same problem. So I have 1.08 here, which means I'm going to have 0.54 amps here, and 0.54 amps here, and 0.54 and 0.54. Because I had 1.08 amps coming in and I split 50-50. 50-50 split, they come back as 1.08. Go in as 1.08 amps. And that's what this says here. So what's the voltage on this thing? Well, I can take 1.08, which is the current through it, and just stick it through 5 ohms and I get 5.4 volts. So this whole thing here, from here to here, is 5.4. Plus, minus, plus, minus, plus, minus, plus, minus. So what's the voltage from here to here? 2.7, 2.7, 2.7, 2.7. So I have all my currents and all my voltages.
So if you have 10.8 volts at the top there, your 10 ohm resistor, but you had 26 going over the other one, wouldn't you still have 26 coming into that one at your point A? Because your voltage splits, or it doesn't really split, it's the
Voltage
same going
doesn't
across.
split, voltage never splits.
Right, so it's the same going across A as it is going down A, right?
No, oh no.
No.
I've got all these resistances in addition to 10. There's only 10 here. This is a lot more than 10. That's 17. Here, well, this is where putting this down is wonderful. At this 10, that 10 is these 2 10s, right? I'm at A and B. Here's A and B, so I'm after A and B, so I'm here. This one's got 1025 ohms, and this is 10. Shoot, that's 2.5 times larger. It's gonna have a lot less current. 1 instead of 2.6. I know I have 3.68 amps here. I took this voltage, I added to that, took them both from 100, came out with 26. Got to be right. 26 divided by 10 is 2.6 amps. When you take 2.6 from 3.6, you only have 1 amp left. And that makes sense because it's gotta push its way through 2.5 times the resistance. That's why it's only 1 amp. We have 2.6 here and 1 here.
Okay.
All right? And that's why putting those nodes helps. Because you can retrace your path. Watts. I have all these equations for watts, any one I wanna use, V squared over R, I squared R, IV, whatever I've got. What do I have here? The watts coming from the power supply is 368 watts, because it's 3.68 amps with 100 volts, so my total is 368. Now I just start subtracting. Here I have 36.8 volts, and the current is 3.68. I could multiply the current times the voltage, or I could take the resistance and multiply it by the current squared. Take the resistance and multiply by the current squared, take the voltage times the current, or take the voltage squared and divide by resistance. Any of those three will give me the wattage. What is 3.68 times 36.8?
135.42.
How much?
135.42.
So I have 135.42 watts twice.
Those are your 10 ohm resistors?
That's my 10 on top and 10 on the bottom. This one is 0.4 watts. This one down here is 135.4 watts. There and there. What do I have here? I have 26 volts and I have 2.6 amps. What's 2.6 times 26?
67.6.
How much?
67.6.
And that's once, because that's over both resistors. That's,
67.
oh, 67. Oh, sorry. And that's over my equivalent 10, because that's 26 over the equivalent of these and 2.6 going through them. Or I could take 13 times 2.6 twice, same thing. I've got that one done. This one, he's 10.8 volts and about 1 amp. That's about 10 watts, call it 11, twice. One on the top, one on the bottom. Voltage is 10, current is 1. What's this do? He's 5. How much current is going into him? 1 amp?
Half an amp.
No, the whole thing is 5.
Okay.
Yep, come back here, that's okay, I know what you're thinking, but there's 1.8 going through this whole thing. So he's about 5.4 watts. 5.4. What does that sum up to be, James? This, from here to here, compared to 368 watts. We're off by 3 watts, 1%. You can do this easily. Do your own method, you don't have to do mine. You can use, I didn't use voltage division, you can use that. I didn't even use current division, you can use that. All I did was subtract one current from the ones I knew. All I really used was KVL and KCL, which happens to be the check. I not only did it, I checked it. And you won't see anything harder 2 months from now.